So now we've already talked about congruency and the two main conditions that we use when we're trying to prove that two triangles are similar. Now, how do we prove when two triangles are congruent? Two figures are congruent if every angle and every side has a corresponding part in the other figure. Now, it's very important to remember when we're talking about congruency, how are the triangles related to each other? They have the exact same size and the exact same angle. But when we're talking about similarity, we said that the figures are equivalent by means of what? The ratio of the sides. So you must know the difference. With congruency, they relate directly. But with similarity, they don't relate directly. They relate by means of the ratio of the sides. Hope you understand that. Once we know that two triangles are congruent, then we know that the remaining corresponding sides or parts are congruent. Right? So once we know that the two triangles are exactly the same, that's what congruency means, they're exactly the same, then all of the other sides and all of the other angles have to be the same. So that's the beauty of proving two triangles to be congruent. Now, the best part of congruency is that you don't always need to know every side or every angle, right? So we can discuss the different conditions that we can use to prove two triangles congruent. First condition, if we know three sides of one triangle is congruent to three sides of another triangle, this is enough to conclude that both triangles are congruent. So if I can prove that three corresponding sides from two triangles are the same, then I can prove the triangles to be congruent. And what's the beauty of it is that I can prove that every angle in one triangle is equal to every angle in another. Right? So from a practical standpoint, you may be given this angle, you may be given that angle. And you need to somehow find that angle. We have insufficient information to prove what that angle is, but we can use what? Congruency. So to find that angle, I'll first have to prove both triangles are congruent. So that's our if and then. If both triangles are congruent, then I can conclude that every side and every angle is the same. So I can find this angle by first proving these two triangles to be congruent. Then I can say that that angle is also whatever, x, which we called it x. Right? So that's what you need to remember. I can also prove congruency by another condition called side angle side. So like I said, you don't need to know every side or every angle. So if we know that two sides of a triangle and the angle between them are equal, then both are congruent. So if I can prove that this side and this side, this side and this side, and the angle between them are the same, then I can prove both triangles are congruent. Again, let's say this triangle, I have an angle here, and I need to find the angle in this triangle. If I can first prove that both these figures or triangles are congruent, then I can conclude that that angle is x. So if I can prove it congruent, then I can say that every side and every angle of each triangle are the same, right? So it's more about finding unknown information, and usually one triangle will have the information that you need for another. So that's what we are using congruency for. Third condition, angle side angle. If we know, can you see in every statement here, I'm using if, then, very important. If we know that two angles and the included side between two triangles are equal, then both triangles are congruent. So I have an angle here, have an angle here, and the side between them are the same between these two triangles, then I can conclude that both these triangles are congruent. You understand the significance of this? If I can prove that two angles and the side between them to be equal, then I can prove these two triangles to be congruent. And the significance of that is every side and angle of this triangle is equal to every side and angle of this triangle. So why do we do this? Because there could be some information here that I need for this triangle. So by proving them congruent first, then I can say, I can literally copy information because they are exactly the same. The next one is angle, angle, side. If we know that two angles and the side not included between these two angles are equal, then the triangles are congruent. So there's the two angles. Which side is not included between them? It's this one. So I can either take this side or that side because it's not included between them. And the reason is angle, angle, side. So there's a big misconception between this condition and this condition. Both, you need two angles and a side, but here the side is included and here the side is not included. So you need to be very careful with which of these two conditions you choose. When we start elaborating on parallelograms, then you'll see when we start solving this, there's a big mess up in the syllabus. So just look out for that, right? And lastly, we can prove congruency with right angle triangles. So if the hypotenuse of two right angle triangles are the same, and if one of the other legs are the same, then both of the triangles are congruent. So all I need here is I need a right angle triangle. I need the hypotenuse to be the same, and either of the legs, either this leg here must be the same, or the bottom legs must be the same. And if that's the case, then we can say hypotenuse leg or hypotenuse side, and that's how you can prove both to be congruent. What's the significance? I can prove that every side and angle of this triangle is equal to every side and angle of this triangle. So there could be information in this triangle that I need in this triangle, but the only way I can transfer that information is if I prove congruency. Right, and so now we can summarize the congruency section. So we have congruency, and we have 5 conditions that we can use to prove two triangles congruent. It's either I must know all of the sides of both triangles, I must know 2 sides and the included angle of both triangles, I must know 2 angles and the included sides of both triangles, or I need to know 2 angles and a side that is not included between both, or I need to have 2 right angle triangles whose hypotenuse are the same and one other leg is the same. And if we have that, then we can prove congruency, right? And again, what's the purpose? Write this down as a statement. There could be information on one triangle that we require on another. So by proving congruency, we can just transfer that information, because by definition, when we're saying 2 figures are congruent, we're saying that they are equal in every respect. I mean, every side and every angle is the same. But not just any side, there has to be corresponding sides and corresponding angles. Okay,